Now we are moving to simplifying rational expressions. Remember, simplifying rational expressions is really not any different than simplifying fractions. When we first learned how to simplify fractions, we remember that we have to divide out anything that's alike top and bottom. So if I start with the fraction 6 over 9, what I'm looking for is the prime factorization of both the numerator and denominator. 6 factors to 2 times 3. 9 factors to 3 times 3. And then remember, all we had to do here, and of course, you're probably used to doing this in your head now. You can look at 6 over 9 and say it's 2 over 3. But when you first learned how to do it, we factored everything in the numerator, factored everything in the denominator, and then said, I can divide out any factors that are the same. Well, of course, I have 3 and 3 here, so they divide out because 3 divided by 3 is 1. And remember, when you either multiply or divide by 1, you have not changed the value of your original fraction. So if I divide out 3 over 3, I get 2 over 3, which must have the same value as 6 over 9. It's just rewritten in simplest form or reduced form. So that's equivalent to 2 over 3. So I'm actually going to do the same thing with my rational expressions. I'm going to factor the numerator, I'm going to factor the denominator, and then I'm going to look at my factors and see if there are any that would divide out because they're actually equal to 1, meaning something over itself. So you can see here it's important that you know your factoring rules. If you don't know those, be sure to watch the videos in my math lab or the tutorial video that was placed in Blackboard for you. Be sure and watch those so that you know your factoring rules. So for my numerator, the first thing I'm looking for is a GCF, first thing I always look for when I'm factoring, and I have one, it's 2x. Now I say 6x squared divided by 2x gives me 3x. I factored out the 2x. And then 4x divided by 2x is 2. Factoring out is akin to dividing out. So now I'm going to look at my denominator. I have 3xy plus 2y. My GCF, or what's alike there, is the y. So I factor that out, and I'm left with 3x plus 2. Now I'm looking at the numerator and denominator and looking for like factors, just like I did up here where 3 over 3 divided out and gave you 1. 3x plus 2 divided by 3x plus 2 is also 1, and I'm left with 2x over y. And that's my final reduced answer on that first problem. So now let's move on to the second one. Again, I'm looking at my numerator. My GCF is 6. That divides out or factors out and leaves me t minus 8. My denominator has a GCF of t. When I factor that out, I'm left with t minus 8. And once again, I have a common t minus 8 in the numerator and denominator, and they divide out. And that leaves me 6 divided by t. Move on to the last one. My numerator doesn't need to be factored. It already is. Doesn't have any common factors, no GCF, so that's b minus 2. When I move to my denominator, this is a trinomial where you're likely to use the AC method, meaning I multiply 5 times negative 8, which gives me negative 40. I'm looking for what multiplies to negative 40 and adds to negative 6. That would be negative 10 and positive 4. So I would change negative 6b into minus 10b plus 4b, or the other way around, of course. And then I would rewrite this trinomial, changing my negative 6b so it has those two numbers. And then I would have a 4-term polynomial, and I would use grouping. I'm not going to show you all of the work on that, because remember, we're expecting at this point that you know how to factor. And if you don't, you should be improving your factoring skills by looking at the videos in my math lab or the video tutorials put into Blackboard. So now, that factor to b minus 2 times 5b plus 4. Again, I'm looking at the numerator and denominator, and the b minus 2's cancel. So I'm left with 5b plus 4 in the denominator, but what does that leave me in the numerator? Everything's gone, so can I just have no numerator? Of course not, because then I wouldn't have a fraction. So once you divide out everything from the numerator, it leaves you a 1. And there are your first 3 problems. Okay, we're continuing to factor and then divide out like factors in order to simplify these rational expressions. If you look at the next one, v cubed plus 27 is a sum of cubes. And if you remember, the pattern for a sum of cubes is to take the cubic root of the first one, that's v, same sign, cubic root of the last one, that's 3. And now remember, my rule is don't look at that anymore, just look at this. Now I'm going to write a new set of parentheses. I'm going to square the first one, that's v squared, use the opposite sign, then multiply the first times the last. V times 3 is 3v, remember number before letter. Always a positive sign, and then square the last one. Okay, let me just go through that again. We took the cubic root of the first one, that was v, the same sign, that was plus, the cubic root of the last one, that was 3. Then I stopped looking at my original problem and went down to what I'd already written. I squared the first term. I used the opposite sign, that was minus this time. I multiplied the first times the last. Now remember here, I'm not looking at the sign because I already decided to use the opposite sign. It's just the variable times the number is 3v. Then always a positive sign, and then square the last. And of course it's always positive because when you square something, whether it was negative or positive, you get a positive. So that's my numerator. Now for my denominator, the first thing I did was look for a GCF. That's always my first step when I'm factoring, and I had one. It was 4v squared. What was left after I did that was v squared minus 3v plus 9 after I factored out the 4v squared. It was v squared minus 3v plus 9, which was not further factorable. There is nothing that multiplies to 9 and adds to negative 3. But as you can see from looking at my numerator, it did give me a common factor in both the numerator and denominator. These are the same. That divided by that is 1, so they divide out, and that becomes v plus 3 divided by 4v squared. And that's my final factored form because there is no longer anything that will divide out. And remember, you might be tempted to cancel those v's, but the v down here is a factor next to the 4. The v up here is part of this binomial. It is not a factor, it is a term in the binomial v plus 3, so it cannot be divided out. Okay, move up here. This has 4 terms, so I use grouping, but before I use grouping, remember I have to look for a GCF. There is a common 4 in all of those, so I factor out the 4, and that leaves me m squared minus 5m plus mn minus 5n. That still has 4 terms, so I use grouping. Well, first let's go down and do our denominator so it won't look so sloppy. I'll have 11 times the quantity m plus n. Okay, back up to the numerator. I had 4, and what was alike in the first 2 was an m, and that's times m minus 5. What's alike in the second 2 is an n, and I have the minus that I want, so I bring out a plus n, and that also leaves me m minus 5 over my 11 times m plus n that I already factored out. So now I have the 4 that I brought out the first time when I factored out the GCF. I have the common m minus 5, and what's left is m plus n, and that's over 11 times the quantity m plus n. And as you can see, these two divide out. I'm going to move this way since I'm out of space here. I'm left with 4 times the quantity m minus 5 all over 11, and that, whoops, is my final factored form there.